Hello, beautiful people of YouTube. Welcome to this episode of the On Deck channel. This is part 2 of the 2-part series dealing with these Epoch batteries, right? Again, for a reminder, it's these batteries. Yeah, and we still have the giveaway going for these batteries. So one of you people out there watching this who have subscribed to the show during the time that we're doing this battery giveaway, which is still right now, so hit subscribe, that will enter you in your chance to win one of the 2 available batteries for this giveaway. So there are 2 chances to win one of these batteries. Do that by subscribing. So in this part 2 of this episode, it's going to be these 2 gentlemen, the ABYC Marine Master Electricians, just going to town on this Epoch battery in this deep dive review. You'll learn all kinds of things about this battery and just in general, all kinds of really helpful things regarding just lithium battery technology. So if you guys would let us know if you have any questions down below. I don't want to ramble. Let's get right into it.
We got no food. We got no jobs. Our pets' heads are falling off.
This is a fairly unique battery on the market in that it is, as I mentioned earlier, it is a dual purpose. So you can use it to start an engine, which is historically have been a big no-no with lithium batteries, mostly because of the limitation of the BMS, but this is a dual purpose. You could use it as a house bank, as well as crank, in this case, probably a fairly large engine. Epoch has in this same line a smaller cranking battery and 120 amp hour, their first dual purpose cranking battery. So this is kind of a successor to that, which in that size would be more suited for a larger house bank or a large diesel engine.
Yep. Yeah, this would be I think this is probably overkill in a pure starting application.
Right.
Almost no matter what size the engine is. But they're being dual purpose means you've got a lot of options. They can be used to start an engine in a pinch. They're perfectly capable of starting the engine all the time. There might be some systems design issues that make that a little bit less advisable, but also other large inrush loads, thrusters, windlasses, winches, cranes, any of the things that might come with a large, particularly DC motor with a big inrush associated. These batteries are going to handle those workloads with no trouble at all. I think historically that's been one of the challenges.
Absolutely.
Is often you've got to have a separate battery for the windlass or some scheme to mitigate that load.
Specifically the bow thrusters, they draw so much load that a lot of the BMSs will cut out. They don't like that inrush current, and but I think this will operate that with no issues whatsoever. So in the fact that it is a dual purpose battery and that is designed to have these large loads pulled, essentially you have a tremendously heavy duty battery. So in terms of robustness, reliability, I think that can go a long way, especially if you have a smaller bank, say 2 batteries. You have 2 heavy-duty batteries that can handle a lot and take, a little bit more abuse than you could trust on a smaller battery. Like for example, this is an example of a 100 amp hour battery BMS, and here this is another 300 amp hour BMS. But just to show the difference here, look at these resistors here on the top, and this is a row of resistors on this brand, and this is the row of resistors on this dual purpose battery. So in other words, everything is kind of overbuilt for the purpose of being able to draw these big loads. We've got 6 pairs of 8-gauge wire and silicone wire. There's 2 large bus bars here. Same thing on the positive and negative side, dual studs with a bus bar, a lot of heat dissipation.
So let's talk about those dual studs for a minute. So we've got 2 positive, 2 negative terminals on top of the battery. On the battery that we've got open, we get the chance to take a look and see how they're connected. There's not some kind of magic here. It's just a bus bar underneath connecting the 2 positive terminals, connecting the 2 negative terminals. So you might be wondering why that's done. One of the things we're going to find out is that some of the spots where we've got single connections in this system are the hottest parts of the system. So by giving 2 terminals in 2 places to make your connection, you're spreading that load out and you're able to reduce any hot spots in the system. That's number one. Number two, potentially they can make connecting your loads easier. ABYC standards limit us to 4 connectors per terminal. In this case, you get to double up on that. One quick caution on that: if you're using a shunt and that shunt is after your negative connection, you don't want to bring any loads around the shunt and directly to the batteries. But certainly if you are series or parallel connecting them, you can almost use like an in and an out terminal on the battery to avoid stacking and keep the connections as clean as possible. Let's take a look at some of the temperatures. We've got 180 amps coming out of the battery, and we have for quite some time. So what are our hottest points, Andre?
We're at about 116 on the board, 116 on the negative terminals. Wow, that's pretty, 94 bus bar.
So it's probably 75 degrees in this room, and we're not all that much over ambient temp there.
No.
I mentioned that sometimes the single points of connection get hot. We know that often our battery switches and fuse holders are the worst.
Oh yeah, in this case especially.
Yeah, so that's 180 degrees,
Yeah.
right? If we were seeing the BMS at 180, that's a little worrisome. But the BMS is a full 65 degrees cooler than the hot spot in the system. And we're keeping these terminals nice and cool because we're doubling them up as well.
Yep. And also let's keep in mind that this is not a typical installation. We've done this just for the purpose of this test. A 3,000 watt inverter, you would not be powering that with a single 300 amp hour battery. You would have, as a minimum, as a design, I wouldn't put more than or less than 2 for a situation like this. But at least, we're basically proving the fact that this battery can handle this load, just in the simple fact that it is a heavy duty battery.
Yeah, we should be clear. We've actually had to work to put enough load on this battery to get it to care at all, right? We've got 180 amps coming out of the battery. We have an air conditioner running outside. We have a heat gun plugged in here. We have a fan out there. So the only reason we're running this as a single battery is to try and drive enough load to really heat it up, to push it to its limits. So the maximum load of this battery is 300 amps continuous. They have a recommended load of 150 amps continuous. We're barely over that recommended load. And we're running I don't know what that is, probably a 12,000 BTU
like yep.
Air conditioner off of this. The inverter certainly feels like heat-wise and sound-wise, like it's working a heck of a lot harder than the battery. And again, we're really deployed in a pretty unrealistic way. At a minimum in a boat, certainly any deployment with internal BMSs, I don't think you would have ever recommended a single battery with a single internal BMS. You pretty much always see those in pairs.
Sure, yeah. In some rare instances we've done it, but almost 99% of the time it's two batteries, 2 BMSs.
Yep.
Yeah.
Yep. And this speaks real positively. Say you have 2 batteries and you had a failure in one of them.
Yeah.
The other one's going to bring you home just fine.
Exactly. There's pros and cons. And Ben and I are going to work on another video together on discussing the different battery types, external BMS, internal BMSs, the different brand, the range of brands. So we're going to have a good discussion about that in another detailed video. So another thing that this battery also includes and has is the networking capabilities. Now, there are, and I very much prefer that connector over some of the traditional RJ45s.
The RJ45s.
A lot more weather resistant.
Yeah.
So
we've all seen, probably, if you've been around a boat long enough, you've seen an RJ45 after a little bit of salt water and a little bit of voltage through it, and they're usually a green mess. This is a really nice. It's a similar to the device net connector that NEMA 2000 uses. Pretty weather resistant, pretty unlikely to result in any sort of major corrosion problems. The battery itself has a link in and a link out port. So if you've got a whole bunch of these batteries, they just daisy chain together. The last battery connected up to the, in this case, to a Victron Servo for Victron comms.
Yeah. Speaking of Victron comms, both of us have had these discussions several times that if if it's not a Victron battery and it's Victron comms, there's a lot of times that there are issues with that. A lot of brands out there advertise Victron comms, and so far with our minimal testing, this one seems a little bit of a leap ahead. And one of the things that I was very pleasantly surprised in seeing with this battery is the fact that you can aggregate the batteries together. What happens with a lot of other manufacturers is you have 4 batteries, you daisy chain them together, you connect it to the Victron, and all you see is one battery. It only displays the one battery. So with a procedure that's detailed in the manual, you can follow the procedure on the app to have each battery recognize itself, and then the battery acts as a pack, and the total aggregate amount is now displayed on the Victron. So that, to me, that was a big bonus. I haven't played with it enough to really see how it functions, but perhaps in another video we could elaborate on that. In addition to that, there will be a really nice display. It's not available yet. I've looked through the instruction manuals. It appears to have a lot of nice features, and I was pleasantly surprised that the price point is going to be about $100. For most people that have a Victron display, they may or may not want that. The one thing that I was very interested about is the fact that it has a audible alarm speaker on the back. And one of the ABYC E13 recommendations is to have an audible or visual alarm if the BMS is close to or an impending BMS shutdown. And this is very rare for this, quote unquote, drop-in style of battery. And like I said, I'm looking forward to exploring it a little bit further to see if it is a possibility that we could actually have that requirement met with ABYC, which would be great.
Outside of lithionics in packaged or drop-in style batteries,
Right.
I can't think of anybody.
Though Victron does have the pre-alarm.
Victron, but that's a system BMS.
Yes, exactly, exactly. Which we'll elaborate more on,
right,
on the next video.
Right, in the battery choices department. But that is definitely an unusual feature. We should probably also, Andre said it exactly right, which is it is an E13 recommendation.
Right.
It is not required for compliance. Frequently, a few of the recommendations get mistaken for requirements, but very nice to have and very nice to be able to meet that. And by the way, ABYC frequently does this, where what's a recommendation in one revision of the standard becomes a requirement in a subsequent.
A lot of people ask me, well, it's not a recommendation, why should we follow it? If you have a surveyor do a survey on your boat, or the insurance adjuster, or you want insurance on your boat, and they're going to look at those recommendations for guidelines and guidance on how your boat should be set up. So although they're not a requirement, it's a good thing to have to follow.
While we've got this battery open, let's take a little bit of a look at some of the construction of the battery itself. So Andre already mentioned we've got 6 8-gauge wires coming up from the pack itself, 6 for positive, 6 for negative. Like almost every lithium iron phosphate BMS, current control happens entirely on the negative side. So the positive is really just a connection right from the pack to the terminals, to the bus bar for the terminals. It's worth calling out, there are temperature sensors on both positive and negative terminals. That's a huge safety feature. If you've got, probably the most common failure point is a loose connection. So that loose connection results in an imperfect connection. That imperfect connection creates resistance. Resistance creates heat. Greater heat creates greater resistance. And then you have a melted case and a blackened wire and real damage. So that temperature sensor prevents that, right? The battery is going to alarm and shut down before you get to the point where you've got a somewhat literal meltdown or melting of the case. So that's great. We then see this quite robust BMS. Under this heat sink, we've got all of our FETs. We've got all of our resistance, balancing resistors across the top. This is relatively new, but all of, in terms of, when I say new, I mean new in terms of what I see when I tear down batteries. But across the bottom, under the FETs, these are all fuses. So in the event of some form of runaway of activity that doesn't get detected by the BMS. The BMS has a lot of protections, overcurrent, short circuit, all those things. But if the BMS for some reason doesn't do its job, we've got physical thermal fuses on the board. Those are gonna blow. At the point where those blow, at least the power handling component of this board is done, but we can also see all of our logic is over here on the right side of the board. All the power handling is over here on the left.
It's nice that there's a separation.
It's really nice, especially if you've got a failure, because now you're only replacing the failed component. We've also got a whole row over here of TVS, transient voltage spike suppressors. So just another indication of the amount of power handling and robustness in this BMS. I want to call it out again. This BMS recommends 150 amps continuous, but is rated for up to 300. This BMS is rated for 100. It's a tiny fraction of the space and physical capacity of the 300 amp BMS. We've also got FETs on both sides, so as heat is created, the FETs are going to heat each other because they're opposing each other. There's just a tremendous amount more robustness that we're seeing here. As we mentioned, with the separation of the board, we also, I noticed it when Andre swept the thermal camera across, this side gets warm, all of our logic is not heating up. It's not getting that same heat bath that we're getting over there. So from an internal construction perspective, there's really very little to complain about here. We see, all the cables are nicely controlled. They're zip tied down. Everything is potted down. I've pulled on the 120, I've pulled the heatsink off. Really robust FETs, high quality FETs, good and consistent use of thermal paste so that we're seeing the heatsink really be effective. And then I want to call out, there's the heatsink across the bottom on the FETs. The top of the battery, there's an aluminum heatsink coming through the top of the case. That is metal. We've got plastic over here, but we've got metal over here being used to actively...
I want to take a picture of that.
Actively dissipate the heat out to the top of the battery. It's another reason when we talk about appropriate installation locations for lithium batteries, if the ambient temp is too high, you're going to sacrifice the ability of the battery to cool itself because a heatsink isn't effective in the same ambient temp.
It's at 104 degrees. So
104.
104, so it's effectively shedding the heat from the battery.
So it's 30 degrees above ambient, and to be fair, this battery was never meant to produce 180 amps with the case open and heat not rising into the heatsink. We're also kind of compromising it that way. But it's sort of a, if it works here, it'll work anywhere kind of idea. And just to harp on it, because I think it really is worth harping on, this is not realistic, right? We would minimally be 2 batteries in this workload, and now you're talking about half the power through it.
Typically the banks that we build would have 4 of these, 3 to 4 is the average, which leaves you with a very robust battery bank. So one of the other aspects I love about this battery is the fact that it is serviceable. Epoch, the company itself, is great to work with. They provide us with a lot of information, parts if needed, so that if there is a failure with the battery, it is more likely to be an electronic problem in the circuit board, whether it be the power management side or the communication side, than it is a cell. So at that point, we can effectively replace a component within the battery, and that you can continue to use the battery. What happens over time is, let's say the battery is 5 years old. The cells within the battery bank are going to age at the same rate, and they're going to have 5-year-old cells, and it's not very conducive to add a brand new battery with brand new cells in a slightly underperforming battery bank because of age. So at this point, you can kind of preserve the amp power and the capacity that you have by replacing the electronic components and then continuing to use your battery bank. So that's a huge bonus.
And if you want proof that Andre and I are both Florida based, we've had this battery open for I don't know how long and been talking about it, and neither one of us has mentioned heat. But we should mention it is a heated battery. We don't necessarily anticipate using that super often, but the orange that you're seeing is the heat jacket around the battery. On the logic board, we've got a relay and then the in and out connections for the heating. There's heating top and bottom. So under charge scenarios, the battery is going to heat itself, which means it can charge in low temperatures. As I say, probably not super relevant for our customer base and our testing, but
certainly in the RV market.
Certainly in the RV market, certainly in some of the northern boating climates, definitely it is germane. And we're seeing one of lithium iron phosphate's real strengths here, which is we've been in this configuration for over an hour now, I think. We're down to 40%, 38% state of charge, drawing 180 amps out of the battery, and the battery is still sitting at 12.9 volts.
It's very impressive, actually, for a single battery.
Yeah.
Like in slightly older lithium bank, I'll see that if you're pulling, in fact, this high of a load, in even much bigger amp hour configurations, you'll see a voltage sag that low. So, I mean, but it is a brand new battery.
Yeah.
But it is impressive.
Yep.
Hope you guys enjoyed this video. Please do like, comment, subscribe. It really helps this channel keep on going. Thank you so much for watching. And once again, that subscribe button will enter you into a chance to win one of these 2 batteries. And we will see you guys on the next episode of the On Deck channel. Sailor Smurf out.